Hello, I would like to demonstrate templating in Cimatron version 13. Let's begin by importing a step file by dragging it into the Cimatron window. And I want to get rid of some wireframe that's here. I'm setting my filter to only select wireframe and saving it. Then we're going to go to New, NC File, and I'm taking a file template which will have some sets or levels automatically created. Then we choose Load Model, and we're going to take this one. Okay, and we're going to make sure we have a certain preference set here. And then we're going to apply a template. Okay, and this template is actually going to create the coordinate systems that are required for each setup on the sides. Now, if the template didn't create those coordinate systems, it is easy to make them. I can create a coordinate system by tool, and I can pick anywhere on the part that I want, and I can create a coordinate system just with the click of a button. Okay, so there's not a lot to do here other than I want to create some boundaries. So we're going to activate side 1 coordinate system. We're going to activate the boundary 1 layer. Okay, we go to composite curve, base is outer boundary, and then number 2. And then number 3. And then number 4. Okay, now this file template already was set up to have the purple. Anything that's purple is going to be violated like clearance. Push a little bit deeper. Anything that's red is going to leave material. So I'm going like 3 thousandths deeper in the purple, staying away 3 thousandths on the red. What I'm machining to 0 is here on the set that I called net. And if we look at that, you can see that's a criteria of those colors. Okay, so let's just double check a couple things here. Clearance plane looks good. Target part looks good. The stock, I'm going to do a box pick from right to left, which means only things inside the box gets picked. And I'm going a little bit more in the XY, a little bit more in the Z minus. And I think of this as a containment boundary for your cutting tools, because you're always going to machine the volume of the stock down to the surfaces. Okay, so everything here should be good. And we're going to execute. And then while that's calculating, we'll open up, we'll launch another session. Okay, and with this one, we're going to drag this one over. And we've got some different geometry. Again, I'm going to get rid of the wireframe, so I don't need that. Save it, close it, launch a new session. We're going to load the model. Okay, and then this one's going to be a little bit more challenging to create the boundary. So let's do this. Well, first we want to apply the template. Let's make sure the preference is set. Okay, again, it's going to create all the coordinate systems for those setups. And we'll activate setup 1, make level B1 active, and then we're going to do composite curve and 1 by 1 projected. So as I pick, these lines get projected out to that plane, and we're going to close it off. Okay, setup 2, boundary 2. And then level 3, setup 3, and then level 4, and setup 4. Now I'm questioning if I did this other one right. So we have a history tree, and I realize that I picked a bad curve here. I actually wanted it to be like this. Let's start over. Okay, there we go. Alright, and then everything here should be good. Again, let's just double check. Clearance plane is good. Target part, you should already know. The stock model, we're going to do the same thing. Picking these guys. Those values are still there. And then execute. Let's bounce back to the other one. Here, the calculation is all done. So we got roughing on all four sides. And then we got the floor milling being done. And as the floor milling gets completed, let's look at the next one. This rough is the 1/8 cutter, and then the 1/8 cutter has a floor path as well. And if we look at that, we'll see that it's just machining the floor where the 1/2 inch cutter wasn't able to do. And we can run this through the machine verifier really fast. Alright, so here's the roughing being done on each side. And it's going to come back and do floor milling, cutting the floors all to 0. And now it's bringing the walls down to the floors that are finished. We'll speed this up a little bit. Okay, now this is the 1/16 cutter, and it's doing remachining. And it's only going to go where it's needed, and it's inserting roughing motions where necessary. I'll slow it down over here to illustrate that. Or actually, that's the 1/8 cutter. So that's the 1/8 cutter that's finishing everything, doing helical motions all the way down to the floors. Okay, here we go. That's what I wanted to show. Okay, so this was the 1/16. So the 1/16 is doing the remachining, and even though this was never cut, the rest milling is able to go in there and insert roughing motions into the ribs. And it gave me a little warning about a collision in the stock area, but I don't think it was very much. We'll take a look at it here in a second. So here I'm getting roughing motions before the finish motions. Okay, and then we can look at the collision list here, and basically what it's telling me is that I had a little bit of a collision with some of the stock. So it just means that it had kind of a heavier cut than expected. But it's not a gouge in the part. Okay, now let's go back and look at the other one. Okay, this one is done calculating, and let's look at that in the simulator. Okay, now it's coming in and finishing the floors to 0, leaving 10 thousandths on the walls. This is the 1/8 cutter. That would be a 1/8 roughing operation. Okay, now this is going to be another 1/8 roughing operation. You notice it's only going where the stock is. And I believe that's the 1/8 finishing operation. and then it's going to do remachining with the 1/16 cutter, and it's only going to cut with the 1/16 cutter where it's needed. Slow it down a little bit. So it actually gave me some roughing motions and then some finishing motions because I told it to only take a certain amount of cut. Alright, and then let's close this one. And let's do one more really fast. And this one's going to be a different geometry. Whoops, I forgot to translate it. So that would be this one. Okay, and let's get rid of the wireframe. Well, actually, no, let's keep the wireframe. Might be a little faster this way. Let's save it, close it, and take the new NC template. Get rid of this, load the model. Alright, and this time we'll do this a little faster. I'll apply the template. Alright, I think, yeah, so this already has the boundaries on the right layers. So it won't take long. Just check the clearance, target part, stop. Alright, and then we'll launch it. Oh, and by the way, we can change the overburn too. If I say edit, spark gap, I can change the spark gap here, and it will push it into all of every one of these procedures for electrodes. Okay, and then we're going to execute. And we won't wait for all these to calculate, we'll just look at a few things. Mainly I just want to show that it's always going to keep track of the stock and only machine where there's material. Thanks for watching.